and welcome back to another in my series of videos about the genetics of chickens. In my last genetics video we talked about gold-laced and silver-laced Wyandottes, perhaps more accurately described as black-laced gold and black-laced silver. But as I hinted, not all lacing colour is black. You've probably heard of blue-laced chickens. And I bet you can guess how that blue lacing is made. It's just like the blue feather colour that we learned about in a previous video. The blue colour comes about because the BL, blue gene, is codominant with the little bl, black gene. If a chicken has only one copy of the blue gene, then she is blue. If she has no blue gene, then she is black. And if she has two copies of the blue gene, then she's a colour called splash, which is almost white. So let's apply this to the lacing colour of Wyandottes. And as we do that, remember that the blue gene only affects the expression of the black eumelanin pigment. The blue gene has no effect on the expression of the gold pheomelanin pigment. Most Wyandottes have black lacing, and of course they have no blue gene. If we add one copy of the blue gene, then, hey presto, the black lacing colour is going to be diluted to blue, and what we have is a blue-laced Wyandotte, more accurately called blue-laced gold, because the lacing colour is blue, but the pheomelanin of the gold ground feather colour is not affected by the blue gene, and is still gold. Now, if we happen to breed two blue-laced Wyandottes, half their chicks would have one blue gene, inherited from either their mother or their father, and those would of course be also blue-laced. A quarter of their chicks would by chance inherit the little BL gene from mum and the little BL gene from dad, in other words have no blue gene, so they are going to look black-laced, even though both of their parents were blue-laced. As we remember, the blue gene doesn't breed true. The chicken must have one copy and only one copy of the blue gene in order for the colour to look blue. And the other quarter of the chicks, who by chance inherit a blue gene from each of their parents and so have two blue genes, what will they have? Since two copies of the blue gene make splash, they will have splash-coloured lacing. And since splash looks almost white, these chicks will look like they have white lacing around the edge of each gold feather. These chicks should be called splash-laced gold. They are very popular because they are so unusual and rather pretty, and as you have guessed, they will breed true, just like black-laced chickens, because the splash-laced chickens have two copies of the BL gene and so will always pass on a blue gene. So if you breed two splash-laced chickens together, all their chicks will always be splash-laced too. So just like before, one copy of the blue gene makes the blue colour, two copies make splash, and no blue genes at all leaves the eumelanin unaffected and so black. Now the splash looks kind of white, but it's not really white. It's a very pale blue-grey, and I think it looks kind of dirty, especially around the hackle. Most splash-laced Wyandottes have quite blue-grey hackles, and I'd like the white to be pure white against the gold ground feather colour. I'd like a gold feather outlined in pure white instead of pure black. And in fact, if you've looked at some of my videos, you might have spotted a Wyandotte hen who looks just like that. Buff gold ground colour outlined in pure white with no trace of blue-grey around the hackle feathers. How is that possible? Well, it needs a completely different genetic background, nothing to do with the blue genes. We need to introduce a gene called dominant white. The symbol for the dominant white gene is a capital I, which comes from the concept that it inhibits the black colour of eumelanin. It's a relatively common gene, although by all means not all chickens that look white have this gene. Of course, you can guess that it's a dominant gene just from its name, but it's not completely dominant, and chickens with 2 copies of the gene will be whiter than chickens with only 1 copy. Its main effect is to inhibit the black eumelanin pigment, but it does actually have a weak dilution effect on pheomelanin as well as its stronger effect on eumelanin, and it's not sex-linked. So if we add this dominant white gene to our gold-laced Wyandotte genotype, what will we get? We keep the gene for the gold ground colour of each feather, which is written as a little s because it's recessive to the silver gene that we already know about, and we keep those 3 genes for making the lacing pattern. We don't add any blue genes, but we add dominant white. The added dominant white tends to white out the black of the lacing, so we get, ta-da, gold feathers outlined in white. Now we do have to say there are a couple of drawbacks. Firstly, 1 copy of the I gene isn't totally effective at whiting out the black completely, and an occasional black speck might show on the white lacing. Secondly, remember that the I gene has a very slight dilution effect on the expression of pheomelanin, so the gold ground colour is diluted a little bit to buff. Unfortunately, if we have a chicken with 2 copies of the I gene, the white lacing becomes less prone to black leakage, but the buff ground colour gets very washed out. All the same, I think dominant white makes a very pretty buff-laced Wyandotte, which should really be called white-laced buff, with none of that dirty grey smudging that you see in splash-laced chickens with a double dose of the blue gene. I bred these buff-laced chickens using the dominant white gene for several generations, including crossing them with gold-laced and silver-laced Wyandottes. I'll share those experiences with you in my next video. Make sure you've subscribed to my channel and activated the bell icon. See you soon!